That's it. Okay. I was telling these fine, upstanding gentlemen that were here on time that I discovered yesterday that there's a second compiler installed on all these computers that I wasn't aware of until I couldn't get, because as you recall, on Monday I had it working and we were able to do a quick little demonstration. I couldn't record it, but they're using this machine. Yesterday I brought in another computer. I installed Windows 7 and tried to record this out there, and it wouldn't compile. It kept getting me unresolved external errors, and then I started getting the same thing on this machine. And what I discovered is that for whatever reason, the version of Windows or Visual Studio is not real compatible with Windows 7 either. It was giving me warnings when I installed it. But there is another compiler on these computers here, and it's called Dev C++ right there. I noticed that the other day when I was at there, I somewhat ignored it, at there because I've never used it. But what I found is that's the one that Sue was using, because I went through and looked at it and saw that that's where all her demos was using. And Sue Raya is the instructor that taught this class the last couple of years. So evidently she was having issues with Visual Studio as well. So I went back yesterday after my class where I looked like a complete idiot, which doesn't take much once in a while. When things don't work right, you got to figure it out. And as I was telling other people, I don't worry too much about that, because I remember probably 4 or 5 years ago, Bill Gates Steve Jobs, this is probably more than 4 or 5 years ago. He's been gone for a couple of years, but he went up to give a demo, and his iPad or iPhone refused to boot up. During a big press conference with 5,000 people in the auditorium and the cameras going, and his hardware failed. So, and I know that there was another case. It wasn't Bill Gates, but it was his person who followed him, that there had the same thing happen with one of the versions of Windows that there. So it can happen to anybody where things broke. But again, there's this program here called Dev C++ 5.11, and what I'm going to do is just have you kind of follow along with me as I do this there. So we're going to go ahead and we're going to create a new project right there. And this one is a little tricky at times that there. We create a new project, and we're going to create a console application, and we can make it either C or C++ right there. I'm going to make it C for today, but as I was looking at the slides for the second half of the class, it's going to go to C++. Most of the slides that we're using are using C++. So has everyone found this program? That there? Some of you that there. So I'm just going to call this, we're going to call it Hari Raya again. Right there, Hari Raya. And I don't know what version of this is. I'm just going to call it Hari Raya. That there. And it's going to come back here, and it's going to, the default is in document C programs. That's where I created that there. So you need to find a directory to put it in. Oh, it's not working now? What? Oh, no. I had it working on that computer there yesterday. Now, let me sit down and try it. Can I steal your slide? Let me see what's going on here. We may have to go at this a different way. File, new. may have to do a save as. One. As. C. There. Project. File. Okay, well, all right. Well, that's kind of an interesting way of doing it. Hopefully we can do it that way. All right. Got there. This, let me try it once from the beginning, then I'm going to go up and do it this way. This is 5.92. This is a newer version of what I'm running. So, file. See if I go there. Oh, it doesn't have C. Oh, this could be a problem. Oh, yeah, now it's working. That's weird. Because now if I say new project, I hit C, PA2. No, I won't give you, okay, it won't let me. No, okay. Right there. So we have to do new source file first. Okay. All right, let's try it this way. All right, I'm going to go. All right. Okay, evidently, what works here doesn't work here. And that's been the story of this software here. All right, but we found there's a way around it. All right, let me start from beginning again. And again, you're running a newer version than mine. Mine's 5. I just downloaded this yesterday. I don't know why I got an older version than what you've got up there. Unless that's a beta version, that's why it's not working right. Okay, for it to work on yours, you have to go about a different way. You have to create a source file first. That's there. It's not letting me create projects, so I'm just going to go ahead and create the source file, include standard io.h, and don't ask me why mine has got some kind of weird spacing issue going there, but you can read that, right? All right. Int main, right there, and printf, this software is a pain in the, well, right there. Right there. Be sure you put the semicolon in that there. And now what we do is under the project, we save as. Right there. And I'm just going to call this pane in the as.c. Right there. And save. Right there. Then when I execute, I would just do I could probably just hit compile and run. And lo and behold, it works right there. This software is a pain in the ... and it executed at such and such a time right there. So that one works. The way that I just did it a couple of minutes ago didn't work on yours. Right there. And I am finding this running C compilers in this room to be a very interesting experience. That there, you know, they don't have the current version of Visual Studio. The last version doesn't seem to work correct, and this one seems to be working differently at your desk than my desk. Right there. And I'm just curious under this help. Right there. I'm just curious. Of course, my internet may be back down again. It would be nice if I was running the same version as you were, but no. Okay. All right. I'm not going to worry about that there. So did everybody get this to work? Your software comes up and says that this is a pain in the butt out there, whatever you want to say, right there. Out there. Again, there's something funny about mine where edit project toolbars, execute tools, editor options right there, add fonts. I'm going to make my font a little bit larger, just simply because it make it easier for you to see, but I don't get much of a line there. What I want to do is try to get these spaces out from in between. That helps. All right. Is that easier to read? Can you read that there on the screen? I could probably make it a little bit bigger. Okay, that's probably about as good as it's going to get to where we got that there, so that's readable on the screen. Okay, so all right, this is there. Now the one thing I didn't do is I didn't do the return 0, but that shouldn't execute, compile, and run right there. And the only thing that this does a little bit different than the Visual Studio, it does tell me what the return value is after that there. If I left that line off, it just, I can tell it to return 5, and again, it's not going to. It just tells me the return value is 5. Doesn't change the execution that there. Now I can't make that any bigger, so unfortunately that's as big as that gets up that there. So, but this is the software we're going to run for doing our programs right there. So it seems, and you were able to do it okay on yours. Yeah, this method. Don't ask me why we have to do such a hokey method, but that's just the way it is. That's not a valid word. I just made it up. That their hokey method. Backdoor. Making it work. I will say, in my 30 plus years of being around computer programming, this is not the first time I've ran across this with a compiler. That there. I've told the story about the Hewlett-Packard compiler that had the software that I had to put the fix in to get it to work, the back door, and then when they repaired the compiler, it broke the program. They had to go back and remove my fix out there. These compilers are just what they are. I mean, they're written by men. They're not out there. The Visual Studio compilers are probably better than this one here as far as accuracy. We may run into some bugs in the compiler out there. The reason is not that Microsoft's such a wonderful company. I mean, and I respect Microsoft. Bill Gates is a brilliant man. I wish I was smart enough that the U.S. government spent millions and millions, if not billions of dollars, trying to figure out how to control the amount of power I had over the computer industry. And trust me that both the American government and the European Union have spent millions of dollars trying to rein in Bill Gates' power over the computer world out there. If you look at the number of lawsuits against him by both the European governments and the American governments up there. But his software is probably the most tested. Everybody uses Visual Studio out there who does professional software development in the Windows world, which is about 80% of desktop computers is Windows-based machines. Therefore, that software is probably the most bug-free out there. This software here is what they call open source. Out there, where you download it from is SourceForge, which is a open source, which is a private, non-profit group of people that basically develop software and give it away for nothing. And you can get the software for free. Out there, it doesn't cost you anything. You can get the source code and you can fix bugs in the compiler if you find bugs in the compiler and you're sharp enough to do that. And then you can post your fixes on their website, and they'll be tested by other programmers who then say, yeah, that's a valid fix, and it becomes part of the release version right there. So it's a public domain type out there. So the price is right. It's free. The amount of tech support you get is equivalent to the price you pay. None. There is no vendor that you can go back and ask for your money back. Out there. I mean, you didn't pay for it, therefore you don't get anything in terms of support. So when you do run into problems, you find yourself on internet forums looking for other users that have found the problem, figured out a way around it. Out there. So using open source software has its own little quirks to it, right there. So there, we've got this to work. Now the only difference would be is if we want to run this in C++, and we'll run some C++. Most of the examples from here on out are going to be C++. So we're going to go through it and look at that there. I'm going to go back to the slides for starting with Chapter 3 up there. Chapter 2 slides basically is just getting a program to run. So hopefully everyone got this to run right there. And again, the easiest way is just execute, compile, and run, and it comes up and just runs right there. So there. So let me jump back to my slides here. And this is tutorial 3. And we're going to introduce, again, we're moving back to C++. So we're going to be using the CN stream out there when I go through this demo. And when we get to the demo, I want you to follow along just as I did here, or do it after I get it done, and test to make sure that you can get this to run before we leave today. That's there. So with that said, I'm going to kind of go through the slides. This is it's inventory program. It's not really an inventory program, but it's just another example program. We're going to be doing a couple things differently here. We're going to introduce variables right there. And then we're going to do some input where someone will type in. We will have to type in some variables. And we're going to do some simple calculations on those variables right there. It's straightforward right there. And then at the end, we're going to go through and use the debugger. Hopefully, I have not used the debugger on this software package. It'll be interesting. You get to watch me learn how to use this debugger. That there, it's I'm not an expert on this package. That there, but most of these debuggers work very similar. I'm not too worried about that, but I could run into another interesting situation. That there. So okay, that there. So we're going to be basically defining variables, inputting the variables from the keyboard, doing some math, store the input. CN is actually our input that there, and we're going to look at the rules of arithmetic operation, and finally we'll try to set some breakpoints right there. Okay, this is a problem definition. This is not unlike what you might see on a exam question. A college bookstore receives cartons of textbooks. In a shipment, each carton contains the same number of textbooks. The inventory manager wants to use the computer to calculate the total number. So basically, he just simply enters two numbers, the number of cartons and the number of textbooks in each carton. It just calculates the total. All we're going to do is multiply number of books per carton times the number of cartons. So this is a long term. You just simply say we're going to write a program to multiply two numbers. That there. Unfortunately, that I've had more than one student fail, get exam questions wrong because they didn't read the question. That there. But the key thing is you're going to see that there wants to use a computer program to calculate the total number of textbooks arriving at the bookstore for each shipment from the number of cartons and the number of textbooks in each carton. So we have two input variables, the number of cartons and the number of books per carton. So we enter those two in, and it just calculates the total number of books. So it's a fairly easy program right there. So it's going to look like this right there. That's the way it's going to run. Now it's going to look a little different than this because, as you saw, we've got the little black screen instead of the white screen up there. Right there. And this would be as if we're running in a DOS prompt, that there. And we're not going to be running in a DOS prompt. We're going to run in just that little command window right there. So the result right there. So that's all that this program is going to do right there. So first thing we're going to talk about is variables. Now, oh, there it is. Okay. Inside a program right there, we have an area right here, and this is our memory right there. Now, if we're taking a course in microprocessors, we would worry about the memory addresses right there. But in a computer program, I can set up a location for this, and I'm going to call this number boxes right there. Boxes right there. And this is going to be a variable. It's a holding place, like a mailbox. I stick information in that there. And I declare these variables right there. So number of boxes, books per box right there. So we got variable names and we got variable types, and we're going to give these of type int right there. Int means integer right there. Integer. So you have two types of integer. You have actually three or four types of integers. Int is the simplest one, and it goes from like minus 65,000 to plus 65,000 or something like that there. We have a range right there. I'm not going to worry too much about that. Then we have unsigned integer that starts with 0 and goes up. Then we have long integers, which has a much larger range. But we're just going to use int. Int, for our sake of argument right now, it's just integer. Later on we'll have float, which is a floating point number right there. And then we can have strings and we can have chars. So we have multiple types of variables right there. But int is what we're going to use to start with right there. Right there. So as we look at int as our right there, so a variable name right there is we have to define a type, and we can also place a optional initialization variable. You don't have to initialize the variable if you don't want to. Right there. Right there. Variable names can contain letters, digits, and underscores. Periods are not allowed. You cannot use periods. Periods mean something else. We'll talk about periods toward the end of the course on C++. Right there. You cannot begin with a number. Right there. Cannot be the same as a C or C++ reserved keyword. In other words, the word true or if. These are reserved words. We can't use those reserved words. And you can tell something is a reserved word when you type in the compiler and it turns blue. That there. That's the easiest way to tell you that there. So this is unique to C. Right there. Identifiers are case sensitive, which means that number boxes is not the same as number boxes. Right there. Upper and lower case are different. If you're working with BASIC, Access, Pascal, Fortran, almost any other language, the case doesn't matter. But C, it matters at there. So just get in the habit that there, as a general rule, almost all variables are used in lowercase, with the exception sometimes the first word or letter in a word might be uppercase, but generally the rule of thumb is that you use lowercase for variables and uppercase for constants, right there. But that's a kind of a guideline. It's not a fixed rule in C. It's just a programming style right there. So, right there. So this is the way that we would normally declare three variables for this example, right there. We have three variables: cartons, items, and result, right there. And you can name these whatever you want to name them, as long as you start with a letter and you use underscore and only letters and numbers, but you can't start with a number, and you can't have anything like int as a keyword right there. Return is a keyword right there. You notice that they're blue showing on the screen right there. If I go back to my right here, you'll see actually it's dark. In this case, they're dark black right there, not blue. The blue is what's in the string, so it's a little different color scheme, but you can see that the return and the int are out there. So in other words, if I wanted to just edit this program and use this program as my starting program, I could just simply say int, and what do they call that? The first one was cartons. Cartons, items, result. Int, cartons, int, items, and int, result. Now, this is kind of the long way of doing it. You can shorten this and put all of the same type on the same line up there. So in other words, I could do something like this, and I'm just going to put this int x, y, z right there, and that's valid too. So in that case, I declared three variables, x, y, and z, or z if you're speaking American instead of English, right there. But that declares three variables right there. So you can do them on, multiple variable declarations on one line, or you could do it one line per declaration right there. I'm going to go ahead and comment this one out right there, because since we're not using it for this one out there. But I'm going to leave it there just to show that you can do that there. Right there. So in this particular case, right there, we declare three variables, and they're all three of type int, right there. This is a short list of all the various variables, right there. Int is the one we're using right now. And then we've got boolean, char, double, float, int, long double, long int, signed char, short char, unsigned int, unsigned long char or long int, unsigned short int, and void. And there's some, and this is a right there. This is actually a partial list, because there's also another type called string, which is actually an array of characters, right there. So you've got a type called string, which is the same as char, and then bracket, which is an array, right there. Or you might see star char right there, which again means that it's an array of characters right there. The star means just a pointer to a bunch of characters right there. So, and sometimes you might see 20 or the size of the string listed right there. So, but we've got these types. We'll get into the chars later that they're in the strings. So, all right, we're back to C++. So C++ uses the stream input command right there, which is this operator right there. and we use CN, which is a keyword meaning the console, right there. So I'm going to go back to my, right here, and I'm going to save as, in this particular case, I'm going to call this pain in the butt, pain in as 2.c++, right there. Now things are a little bit different because this is not valid anymore, right there. So, and actually, I screwed up. Save as. That should be CPP. You know, I put in C++, but it's CPP right there. Just right there. You can use, as you well guess, I don't use C++ a great deal because embedded systems are almost all C right there. So, I'm just changing that there just so that we can, right there. So again, basically, what we're going to do here is that this is our command to enter that in, right there, inputs right there. So we're going to use this command right here to get the number of cartons right there. So it takes 2 lines. The first line is an output. We're going to say, ask the user how many cartons there are, and then we're going to read the input right there. So let me just go through and just add that in right there. So let me just go ahead and delete that there. And we're going to say C out right there. Enter the number of, I'm going to say boxes right there. Right there. And that should be all we would need. And CN right there, and cartons. That should be, make sure I got this right. Right there, yeah. So if we execute this right here, and CN was not declared, see how we are missing something right here. And I know what we're missing, and this did not tell us what we're missing. Right there. And I can't remember. Oh, we're missing the include IO string. That's what I'm missing. I include IO string. Right there. That should. CN is not declared in the scope. All right, now I'm going to get frustrated because that should be working just perfectly fine. Right there, this is our working code. CN carton, bracket carton. Did I put that the wrong way? I forgot to use namespace standard. Let's just copy directly right there. Right there. And we want to using namespace standard. That's all we want. Okay, now we finally got there, and just kind of remind myself, because I said I don't use C++ very often. That I'm in the habit of every time I write C programs, I always include standard IO.h, with C++, you always got to include those two lines, include IO stream, and then using namespace standard right there. I just, for whatever reason, it's 8 o'clock in the morning. I don't think very well, or not. It's almost 9 now. I've been awake for 2 hours, but my brain still hasn't turned on. I've only had 1 cup of coffee so far up there. But regardless, you have to include those two lines with any C++ program up there. Just get in the habit of any time you start writing C++, you have to include those two lines at the beginning right there. And I knew as soon as I started writing this, I was missing something right there. So I'm just going to set 34, and it didn't do anything. My program did not do anything because I stopped at this point right there. So now we can just go ahead and repeat this to get the number of items per box right there. So cout enter the number of books in each box right there, and cn items right there. So this is going to get me the number of books. I should be able to run this again right there. So I got 50 boxes and 100 books in each box. Now it doesn't calculate the value yet right there. So our next step is to calculate the result, and the result is equal to cartons times items right there. That's our result at that point right there. And we can do a cout right there. The number of books is equal to, and then we're going to then do a item or a result. And I'm going to go back to the slides before I run this, just right there. Right there. So we go through and we've done this so far, right there. Right there. So number of items, result, and then we have to add our n line. In this case, we're going to add 2 n lines right there. Right there. So hopefully this works perfectly fine. If not, we got 10 boxes, 20 books in each box, and we've got 200 books total right there. So that's our entire program right there. So if that was given to you on a final exam question, this is what you would submit right there. You know, again, the syntax will come more natural as you do more programs. Warning that there, I've worked with probably 10 different languages over the decades, starting with Fortran on punch cards, and then Pascal on a terminal, and then Basic, Quick Basic, Visual Basic, VHDL for custom chip design, Verilog for chip design, various assemblers. Me and syntax are not good friends. I do not memorize the syntax for every language that I work with. So as I type, you'll see me double checking syntax and running programs, getting syntax errors and going back and fixing them. I've gotten in the habit of fixing syntax errors. Syntax errors drive young students crazy because you sit there and you fight with them. But after a while, you get to the point that you can find them fairly quickly and fix them up there. Syntax errors should not be a big issue once we go through it up there. So this is really right here. Now, as we execute this program, we've got this right there, and this debug is right here. I can put breakpoints in here, for example, right here. I'm going to put a breakpoint right there. A breakpoint means that it's going to stop running at that point there. And here, and I've got my debug function right here, and I can add a watch. So add watch, and my watch is going to be cartons right there. Actually, I can just highlight that and hit add watch. And, well, I guess, well, this is my interesting thing right here. Let's start this over again. Let's go back and run this again. Open. And this looks like, okay, this is the right one. Project. Execute. Okay, this is the right one. Debug. All right, so that didn't do anything. Add watch.
Yep.
Right there. And let me, as soon as I go to correct that, it's going to crash. Evidently, our debug may not work right. I may have to spend some time on the debug right there. Right there. Which doesn't surprise me. As I said earlier, execute, compile, and run. $450. That's working. The debug tool, let me just talk a few minutes about the debug tool, and then I'm just going to let you play that there. The debug tool allows me to step through this right here. If I go through on debug, right here, F5, I can step through the code one line at a time and look at the variables and what's going on. However, in other words, I can set breakpoints right here. And I can just set breakpoints wherever I want right there. This just tells us to stop executing at that spot right there. So if I hit this, it stops. It's right there. If I hit 5 and enter, and it's not setting that right there. Evidently under parameters, debug, no, we don't want to pass that there. Project, tools, environment operations. Show during compilation, font, check, directory, that's fine, external, that's fine, C++, okay, right there, passing. I'm not seeing where I can set the debug. Right there. Because if I hit debug, it just runs that there. It stripped it. You have not enabled debug info and or stripped it from the executable in the compiler options. Right there. Compiler options. And tool, compiler options. And evidently, add a compiler, add a blank compiler, trash. This is using, right there, programs, GCC. Evidently, it's, I need to do some more research on adding the debug options out there. Right now, we're not going to worry about debug options right there. It's very easy to use debug with Visual Studio. This one looks like it's a major pain in the tush. Yeah, because it works perfectly fine, but the debug is not. Because as soon as you've not enabled that there, you want to correct this, as soon as I see I want to correct it, what does it do? It crashes. So evidently it's not going to let me add the debug options with this version. Can you add the debug options on yours without crashing? It crashes as well. Okay, yeah, so. But it executes fine if you tell it to compile and run it. Oh. It flips right through there, huh? It shows the answers, but it doesn't. You know what? Yeah, I mean, it looks like yours is working okay. This is version 4.92 right there. Yeah, okay. Right there. Stop there. Oh yeah, see, now we're seeing that there. It's still not cooperating very well. It's not breaking. See, now it shows the number of cartons that there as we go through that there. And then debug. Next step right there. There, of course, go through that there. So debug. and then of course it's pointed. Yeah, yours is working, mine's not working. But again, compile, but execute. Yours is different than mine. That's good. Great with it. All right. Let's not worry too much about the debug for right now. Yours is working, but it doesn't. Right there. So it appears that yours is running a little different than mine, huh? Because I've got version 5.11, which it looks like I need to download. You say that's 4.92, 4.92? Right there. And that was 4.992. Yeah. Let me download that one before I go any further. Unfortunately, I have to scan this before I install it because it didn't come from source up there. So it may very well have other stuff added to it. I need to have the same thing. Guess what? It had other stuff added to it because my antivirus blocked it. Right there. Right there. Yeah, my antivirus turned right around and said no. Well, I need to get the same version as you do. This is version 5. I'll get the other version before tomorrow. I'm not going to worry about that there. Everything else is fine the way we are, except for what we're going to find here. Let me open that back up that there. Right there. The only thing that you've got going right there is that you need to do another CN junk right there. And I'm just going to put a int junk right there. And the only thing that does is if you do a CN junk right there, you have to hit a number and then enter it in order to stop the screen. That way it doesn't fly right by. It's waiting for another input right there. So if you run this right here, right there, and it doesn't have int junk. Oh. Right there. So I hit 5, 2, and then 15. It's waiting for me to hit another number right here. So if I just hit 3, and then it'll. So all we're doing is just forcing it to stop before we got there. We may have to do that with your version because you're supposed to be able to run this without debug, and that there. Mine is defaulting to run without debug, but I can't run debug. Yours is defaulting to run with debug, which is what I would prefer, but we have to put the stop in. So let me repeat what I just said where it makes some sense. My version is running without using any debug. I can't turn the debug on for some reason on this version of the compiler. So as a result, and it may very well be that this particular, because under compiler options right there, there should be a thing there to turn on the debug. And it may be just something as simple as right there. And if I do no such file or GRA, it doesn't like that there. So I can't that there. But under my filing options right there, there's a setting that allows me to recognize all inline as keyword of the traditional C processor right there, imitate traditional directories. I don't, oh, I'll tell you what here, let me try one more thing here. There's the debug option right there. Right there. Yeah, I'm not going to waste your time. All right.